Okay, so in this video we will solve boundary value problem uh, using the initial value problem approach. So initial value problem means the ODE was that dy over dt is equal to f of y comma t. So here the problem was that boundary condition for this was given that y at t is equal to 0 was given. Similarly, if it was of order of 2, then an initial value problem, that is called IVP initial value problem, that y at t is equal to 0 was given and dy over dt at t is equal to 0 was also given. So this was my initial value problem. But what is the BVP? Boundary value problem is, suppose I have d2t over dx square minus atx is equal to f of x, and the boundary conditions are given, not the initial condition. So initial condition is also given, that is t higher, and t at x is equal to L is given, that is t cold. So my boundary value problem has a form of d to t over dx square minus atx is equal to f of x, where t at x is equal to 0 is equal to th, t at x is equal to L is equal to tc. Now if we want to solve this using IVP approach, then first we will have to convert dt over dx is equal to u. This implies I have du over dx is equal to atx plus f of x and the second problem is that, so this is my first problem where t at x is equal to 0 is given as th and du at dx is equal to d to t over dx square is not known, but there is additional info which is given, that is tx h is equal to L is equal to tc. So if you can see that the IVP is the system of initial value problem comes out like this, but here we have a problem that du over dx is not known at x is equal to 0, but there is an additional information that is given as t at x is equal to L is given as tc. So BVP to we have converted IVP, but the problem is that we don't know dt over dx at x is equal to 0. So this IVP is not defined properly. So what we will do, we will try to find the dt over dx using additional info that tx at x is equal to L is tc. So whatever value of dt over dx at x is equal to 0 satisfy t at x is equal to L is equal to tc, and the solution corresponding to this IVP will be my final solution. Now this method is called sorting method. So let me describe the steps involved in this. So what we were doing, we had an d2t over dx square is minus atx is equal to f of x, that has t at x is equal to 0 is equal to th, t at x is equal to L is nothing but Tc. So from this BVP I converted that dt over dx at is given as u, where t at x is equal to 0 is nothing but th. The second part is du over dx is equal to atx minus fx, where u at x is equal to 0 is u naught. This is unknown. We will assume this to satisfy t at x is equal to L is equal to Tc. So what is the algorithm? So first step is that gas u naught dt over dx at x is equal to 0. Second step is solve system of ODEs, that is dt over dx is equal to u, t at x is equal to 0 is equal to th, du over dx is equal to atx plus f of x, where u at 0 is equal to u naught. Now solve this for initial gas u naught and find the calculated value of t at x is equal to L. So suppose t at x is equal to L is coming out to be Tc tilde. So my third step is that at x is equal to L, error, which is nothing but epsilon, is Tc tilde minus Tc, because Tc tilde is calculated value which was computed based on the assumption that d u over dx is equal to u naught at x is equal to 0. So this epsilon is nothing but Tc tilde minus Tc, and that is nothing but a function of u naught. So we want to find out the value of u naught where Tc tilde minus Tc is going 0. That means we want to find root of f u naught is equal to 0, which means root finding problem. That means u naught new will be equal to u naught old minus f of u naught old divided by f prime u naught old, where remember this f is nothing but error. So u new is updated till we get u naught new minus u naught old less than epsilon 1. So based on this Newton Raphson, we will try to compute the new value of u naught. Now this is nothing but, that means u new is nothing but u old minus error at old divided by error prime at old, or u old minus epsilon old divided by d epsilon over du. This is u naught. So what is d epsilon over du naught is nothing but epsilon at u naught plus f delta minus epsilon u naught minus delta upon 2 delta. So my u naught new is nothing but u naught old minus epsilon old epsilon u naught plus delta minus epsilon u naught minus delta divided by 2 epsilon 2 delta. So this u new is equal to u old minus epsilon u naught old divided by epsilon u naught old plus delta minus epsilon u naught old minus delta divided by 2 delta. So we will iterate till u naught new minus u naught old becomes 0. So this is my third step, and as soon as this becomes 0, u naught new is my true initial gas, and this will satisfy t at x is equal to L is equal to Tc, and we have a solution. So what is my algorithm? So algorithm for this is that first provide the data associated with problem, BC's equation and constants are provided. Then we take initial gas u naught old we solve for dt over dx is equal to u naught with u naught is equal to u naught old, u naught is equal to u naught old plus epsilon plus delta, u naught is equal to u naught old minus delta. 3 IVP's initial value problems are solved, and once we solve 3 initial value problems, we find out error t at x is equal to L minus Tc for all 3 IVPs, and these are given as epsilon. So the next step is that we calculate u naught new as u naught old minus epsilon u naught old divided by epsilon u naught old plus delta minus epsilon u naught old minus delta divided by 2 delta. Check u naught new minus u naught old less than epsilon 1. Yes. Solved equation. No. Then my u naught old will become u naught new, and I will go to this point. So this is my algorithm. So first the data and boundary conditions and the equations needs to be provided. Then we will take the initial gas, that is u naught old, and then we will try to solve the initial value problem for the initial guess as u naught old, then u naught old plus delta, then the third IV will be u naught old minus delta. And for all these three initial value problems, we will calculate the error epsilon, that is given as the computed value at x is equal to old minus the given value. So we have the epsilon corresponding to u naught old, we have the epsilon, that is error corresponding to u naught old plus delta, we have the error corresponding to u naught old minus delta. And once we have these three errors, we can compute the new value of u naught, that is given as u naught old minus epsilon u naught old upon epsilon u naught old plus delta minus epsilon u naught old minus delta upon 2 delta. Once we have calculated the new value of u naught, we will check for the convergence, that is u naught new minus u naught old. If it is less than epsilon 1, then we have got the convergence. If it is not less than epsilon 1, then we will have to assign the new value of u naught to the new old value of u naught, and then we will have to repeat from this step where we will be going from this. So this is my step, and this method is called shooting method, used to solve boundary value problems as initial value problems. So this is how we can compute. Okay, so thank you very much. We will meet in the next video.